I can't name the institution. This is a West Coast research campus. They had a data center that was actually doing okay on physical space, but they were absolutely, completely at the limits of the electrical power that they had in the room and the HVAC systems that they had to the room. So they knew that they had a tremendous amount of stuff that they had to onboard. Next-gen sequencing was just starting to come in. What they ended up doing is they sat down and they built out and they architected what they called a virtual co-location facility. They actually did it with kind of good high-end hardware, best practices all around. It's VMware ESX running on NetApp storage. Very, very aggressive, thin provisioning, deduplication, sort of. They're being very, very aggressive about the storage that's going on under the hood. The payoff is amazing. There are more than 400 servers running on this relatively lightweight, simple platform. I think they've shut down close to 180 physical machines, and you can actually tour the machine room and actually see the empty racks where they've sort of retired from service and pulled these machines out. Tremendous savings, especially in being able to do deduplication, content optimization, and even thin provisioning. There's a lot of sort of one of the benefits of sort of centralizing and pooling your storage is you can get very, very sort of efficient and aggressive in sort of how you optimize stuff. There's a lot of sort of waste and inefficiency you can remove with the right software. The electrical and HVAC savings were tremendous. I mean, they were actually the driver for the product, but I think that the project sort of paid for itself within the first couple of months just on electrical and facility costs alone. And the really nice thing about virtualizing this environment is that it really is a co-location facility for research scientists. The IT organization is able to fully hand over either a collection of servers or individual servers with full remote power, remote console, full administrative control. They hand incredibly powerful platform, server, and systems tools to their scientific community, and the scientific community doesn't have to give up anything, and basically everybody wins. It's actually this virtual colo service. I wish I could talk a little bit about more. These are the type of people that I'm always hitting up to come give talks at BioIT World, so maybe expect if you come to BioIT World next year, look for one of the tracks on vColo or virtual co-location services. Hopefully they'll talk a little bit more publicly about what they're doing. I think I've talked a little bit about this in the previous slide, but one of the sort of pain points in a research IT environment is that there's a lot of stuff that scientists need to do involving building services, web servers, and little database services that are incredibly important to the workflow. They're incredibly important to the science that's going on. But at the end of the day, they're little MySQL databases. They're little web apps written in Ruby or PHP. They're vital to the scientific workflow, but they absolutely do not rise to the level of an enterprise application standard. They don't meet the security requirements. They really don't meet any of the requirements. And one of the nice things, and that's always been a problem with some of the larger IT environments that I go into an environment and there is an absolutely scientifically valid use case for giving a scientist full administrative control over a Linux server with web, Apache, MySQL, the full LAMP open source web publishing stack. But IT is traditionally sort of resistant to give people root level access. They don't want to give people the ability to turn the web server on and off. And what virtualization allows us to do is it really allows us to solve this problem. I can create an enterprise blessed Linux or Solaris or whatever environment I want. I can snapshot it. I can hand it over to the user. And the contract between corporate IT and science IT is very, very basic. We give you a server, it's fully patched, it's up to corporate standards, you can do whatever you want within it, but if you break it, we're not going to fix it for you. We're just going to snap you back to the working snapshot that we had before. It's a really, really nice way to delegate administrative control and sort of the technological tools that the scientists actually need without forcing corporate IT to get down and dirty with debugging badly written PHP scripts and Ruby and things like that. And it's one of the benefits that I really, really see is that virtualization is a fantastic tool for bringing tools to the scientific end users who need to build these little web services that they need. They're vital to the science, they're vital to work group level stuff or departmental level stuff, but they absolutely don't rise to the level of being an enterprise level application portfolio. Virtualization is sort of the perfect way to sort of solve that issue, and it makes a perfectly clear line between support too. We will give you the VM. If you break the VM, we'll revert you back to a known good VM. Other than that, you're on your own. All right, I'm going to skip over this a little bit. I've already talked over it. In terms of the coming soon stuff, some of the stuff that I've seen, there's actually people in the room who are going to know about some of this stuff. I'm working on a project now with a very, very large cluster that's moving. And the cluster has 7 physical head nodes. There are 5 nodes that users log into, and there are 2 nodes that are used for the administrators. The first thing we're going to do when we move this cluster is that those 7 head nodes are now going onto a VMware platform, and we can spin them up on demand. The more forward-looking thing is we're considering the possibility, or there's people in the audience I've had discussions with about this, about why not take this to the extreme? Why not give every single scientist their own VM? Let them put their development library, their own tools, their own environment in there. We can back it up, we can secure it, we can snapshot it. If the user breaks it, I can revert it back to something that we know is good. In terms of hype curve stuff, where I don't think we're actually sort of here, is that I spend a lot of my day working with clusters and grids, and people are always asking about, when are we going to start wrapping applications up in VMs and just shooting the VMs off across the grid? It's technically feasible now, but it's not eminently practical. This is probably one of the things where the marketing sort of wins out over the actual practical stuff. I don't see people running VMs as cluster jobs, at least within the short to near term. It's you lose too much performance and you add too much administrative hassle for the benefits that you would supposedly gain from doing that. All right, moving on a little bit to the storage side of things. Some of the sort of milestones for us as a company in 2008, it was the first time that we built a 100 terabyte single namespace storage system. Coincidentally, within 30 days of the 100 terabyte single namespace, we actually got involved in building our first petabyte scale single namespace storage project. Our storage consulting increased fourfold in the pace of about a month or two. And finally, the more interesting thing is it's the first time we saw massive loss of scientific data, and the first time ever I've seen IT people lose their jobs over a sort of catastrophic scientific data loss. I'm going to talk a little bit about the background as to how that data loss happened, what we do now to prevent it, and basically so that we don't see any more dismissals related to data loss. And finally, data triage is something that I've talked about a lot in previous years. We're at the point now where we're generating data faster than we can reasonably store it. It's actually pretty easy to store it. It's actually very, very difficult and expensive to back it up, to make it reliable, to make it available. And data triage was something that some of our more forward-thinking customers were doing back in 2006 and 2007. And I thought that it would have a lot of resistance going into academia and some of these other institutes. The really good news to report, and I'm going to talk a little bit about this more in the future, is that one of the reasons why the storage deluge that we're under is not so scary is that it seems like everybody I've talked to, from IT to scientists, has come to the realization that data triage is a given. There are absolutely going to be some use cases where it's cheaper to go back and repeat the chemistry than it is to keep that data online, archived, DR'd, backed up, replicated forever. This is my favorite slide. I think one of my favorite slides. I think scientists love this. This is a Mac OS desktop folder showing 82 terabytes of free space. Large single namespace, avoiding the whole 30 different NFS mounts, having to put data in 30 different locations. From a scientific perspective, single namespace, big pools of data, giving scientists the ability to organize the data the way that makes sense to them, while maybe under the hood you're doing deduplication and content optimization that's kind of invisible to them. That's a fantastic tool. So I love showing this slide. Mac slide, 82.43 terabytes free. There's probably people in this room who could fill that up in a day or two, but it's still a pretty nice slide. Even better than this slide, though, first time ever I've seen a P in the output column. This is a 1.1 petabyte volume mounted on a Linux system. I still think that's very cool. I can't wait till I see more of those floating around.